Hello, we are going to kind of tie everything together here using the fundamental theorem of algebra. And what the fundamental theorem of algebra says is that you must have as many solutions as the degree. So for example, the degree here is 5. So that means I better have 5 solutions. Now that doesn't mean I'm going to have 5 x-intercepts. Because those are real solutions. It means some combination of real and imaginary solutions must add up to 5. So first, I have this big polynomial, x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4 equals 0. If you notice, I don't know if you want to try factoring something like this. I mean, certainly you can see that these have an x squared in common, so let's just try it. And if I pull out an x squared, that leaves me with, I'm sorry, they have an x cubed in common. So if I pull out an x cubed, that leaves me with x squared minus x minus 3, and over here they do not have anything in common, and so that would leave me with plus 1, and so that right there is not the same as that, and so I can't factor by grouping. And so there may exist some method that would allow me to factor, but when you have one like this, this is what I want you to do instead. We are going to come over to our calculator, and we are going to plug in y equals x to the 5th minus x to the 4th minus 3x squared plus 3x, 3x cubed, sorry, plus 3x squared minus 4x plus 4. And we're going to graph this. And what we're looking for are real solutions. So x-intercepts. And if you can see, it crosses here, here, and here. And it doesn't slide. See how that right there is a slide, but it doesn't slide across the x-axis. So the fact that it crosses, crosses, and crosses, this means that there are 3 zeros. Remember that if it crosses, that represents 1 0. If it just touches, so if it would curve up here and just touch the x-axis, it would represent 2 zeros. And if it slid across, similar to how that looks right there, it would represent 3 zeros. But here, we can run our calc to find out. Second traced, go to 0. We want to move our cursor until it's to the left of our x-intercept and hit enter. Then we want to move it till it's to the right and hit enter. You should see these two little arrows. They should be surrounding your 0. Make a guess. It crosses at -2. So I know that x equals -2 is one of my real rational solutions. So we're going to go ahead and do the calculations for the other 2 zeros as well. Okay, so once I ran those calculations, this has 3 real rational roots, -2, 1, and 2. But the problem is we know there has to be 5. And so we know that there must be 2 imaginary solutions. So what we're going to do is we're going to run division. Polynomial long division if that's your cup of tea, or synthetic division if that's what you prefer. If you're going to do a long division, you need to turn these zeros into factors. So it would be x plus 2 would be a factor. That way you could divide. That's the one that goes with that factor. This one would be x minus 1. That's the factor that goes with the 0, x equals 1. And then x minus 2. That's the 0, or that's the factor that goes with the 0, x equals 2. Because if I set each of these factors equal to 0 and solve for x, I would get negative 2, 1, and 2. So if you're going to do polynomial long division, you're going to want to turn those zeros into factors. But I'm just going to do synthetic division. And what I'm going to do is, because these are zeros, my remainder should be 0. Because these are going to be factors, right? If it's going to cross the x-axis perfectly at these points, that means if I divide by all of these, I should get 0 remainder. That lets me know if I'm doing it right or not. And then what we'll be left with at the end is hopefully something that you see that you can use. So I'm going to write all the coefficients. I'm going to do synthetic division. 1, negative 1, negative 3, 3, negative 4, and 4. And I don't have to add anything because see it goes 5, 4, 3, 2, 1, 0. And so I don't have to add anything. So I'm going to first divide synthetically by negative 2. So I bring my 1 down. Negative 2 times 1 is negative 2. Negative 2 plus negative 1 is negative 3. Negative 3 times negative 2 is 6. Negative 3 plus 6 is 3. Times negative 2 is negative 6. Plus 3 is negative 3. Times negative 2 is 6. Plus negative 4 is negative 2. Times negative 2, oh, I'm sorry, it's not negative 2, it's just 2. Negative 4 plus 6 is just 2. And negative 2 times 2 is negative 4, and negative 4 plus 4 is 0. So I got a remainder of 0. That's awesome. That's what we wanted. Lets me know I did it right. So now I'm going to run synthetic division again, but this time I'm going to use 1 as my divisor. Bring down this 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. 3 plus negative 2 is 1. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. Negative 2 plus negative 2 is a remainder of 0. Awesome, I did this one correct as well. So I took my new polynomial. You don't include the remainder in your new polynomial. It would be x to the 4th minus 3x cubed plus 3x squared minus 3x plus 2, remainder of 0, and I divided by that factor. Man, and I got a remainder of 0. So far, so good. So now let's do it one more time, but we're going to divide by 2. Again, we should get a remainder of 0 because these were all factors. They all cross the x-axis. So I bring that 1 down. 2 times 1 is 2. Negative 2 plus 2 is 0. 2 times 0 is 0, plus 1 is 1, and 2 times 1 is 2. Negative 2 plus 2 is remainder of 0. Again, we don't include our remainder in our new polynomial, x cubed minus 2x squared plus 1x minus 2, remainder of 0. And so now, I've successfully divided that one. So now I know my new polynomial is x squared plus 0x plus 1 with a remainder of 0. So x squared plus 1. Let's kind of bring that up here so we can do work with it. X squared plus 1. I'm going to set that equal to 0 and solve. A lot of times you'll end up with a trinomial that you can factor or do quadratic formula, but this is nice that we end up with just a binomial because now we can just solve. Now, and you can see how this makes sense. Here's 1, 0. Here's 2, 0. Here's the third 0. And I know that this is going to have 2 zeros, which will give me a total of 5, which is what I wanted. So it looks like it's all shaping up to be great. So let's do that. Let me get rid of it. So x squared, I'm going to subtract 1 from each side. X squared equals negative 1. I screwed it. So I get x equals plus or minus the square root of -1, because anytime you take the square root of something, it's plus or minus. Now you've got to worry about simplifying this nasty negative square root. Well, remember, to pull out the negative, you're just going to pull out the I. X equals plus or minus I square root of 1. Well, square root of 1 is just 1. So that is just 1, and 1 times I is just I. So X equals plus I, and X equals minus I, because, you know, plus or minus I. Let me put the negative in there. And so now that's 0 number 4, and that's 0 number 5. So something that we couldn't factor, we started with this that we couldn't factor, we plugged it into our calculator, found the 3 zeros. We knew that if we do polynomial division or synthetic division and divide by our zeros, we should get remainder of zeros and give us a polynomial that we can work with at the end. X squared plus 1 is something that we can solve. So that is how this whole unit ties together. Factoring to solve for zeros, graphing and looking at x-intercepts to solve for zeros, using synthetic division and zeros together to get to a polynomial that will allow us to solve for the zeros that don't show up on the calculator. So I know this might seem a little confusing, but that's what all of this is for, is to find the solutions to polynomials. That'll be it. Let me know if you have a question. Thank you.